Hi, welcome back. Um, Now let's do some examples of integrating a double integral over a region that is not a rectangle. So we're given a function and we're given a region that's defined in terms of some curves. And what we'd like to do is figure out what is the net volume under this surface above this region. So here are the steps you should always go through when you're working on such a problem. First thing, we want to understand the domain of our function. Uh, Really, the function that we are integrating over is maybe one of the last things that we think about, unless it's really complicated and we think that that may be where the issue is in doing our integration. But in most cases, a lot of the setup has to do with drawing a picture, understanding the domain, and knowing where the slices are. All right, so we need to plot these functions. Y equals 1 plus x squared, y equals 2x squared. Now 1 plus x squared, we should think parabola shifted up 1 unit. Whereas y equals 2x squared, that's a parabola that's been had a vertical stretch of a factor of 2. So if we're plotting these functions, we see y equals 2x squared, looks like that, y equals 2x squared. And then we have y equals 1 plus x squared. It's going to look like this. All right, so we now have our region that is, this is our domain D. Okay, so when I look at a region that looks like this, what I immediately start to think about is, am I going to do some vertical slices or am I going to do some horizontal slices? Depending on the picture, I'm going to look and see, if I put a vertical slice in here, do I always go from the same lower function to the same upper function? All right, so if no matter where I put my vertical slice here, do I have the same lower function as the same upper function? And as I start to fill in some teeth here, haha, it looks like a mouth, I start to see that when I make these vertical slices, that is the case. I always have the same upper function, I have the same lower function. So that means that I'm on the right track, that I want to slice vertically. Let's consider what would happen if we tried to slice horizontally. So if we tried to slice horizontally, well, down here we do have this parabola as this side of the parabola as my lower function. I have this side of the parabola as my upper function. So when I'm down here, let me make those also blue. When I'm down here, I do fit in that same idea that I have the same lower function, the same leftmost function, as the same rightmost function. But when I get up here, I start to see that my region doesn't behave very nicely. I have a different lower function and a different upper function. That pair is different from when I'm down below in the blue region. So what that's telling me is that it doesn't make sense to do horizontal slices. It makes sense to do vertical slices. All right, so we're going to make some vertical slices. And so you're going to hear a lot about chopping. I'm going to do a lot of chopping. And what I've decided is I need to make vertical slices. So I've made my vertical slices, and based on my vertical slices, I know I have to start chopping somewhere, and I have to stop chopping somewhere. So I drew my picture, determined the orientation of the slicing, determine the slicing, and because now I need to know where I start chopping and where I stop chopping, I realize I need to find the points of intersection so that I know where my x value is. What is this x value? What is this x value? So I need to, as I say, vertically, and so I need to figure out where are the intersection points so where do I start chopping? Okay, so where do I start chopping, where do I stop chopping? And where the bounds of this region are determined by the intersections. So 2x squared equals 1 plus x squared. I have to set these two functions equal to each other. So I get x squared is equal to 1. So this is x equals plus or minus 1. So what that's saying here is that I start at x is equal to -1, and I go up to x is equal to +1. All right, so that's where I start chopping, that's where I stop chopping. Now, for a vertical thing here, for a vertical slice here, I now need to look and figure out where the top part of the function is, where the bottom part of the function is. What's the top function, what's the bottom function? And here I've labeled these things, which I've labeled them, but I didn't do a very good job of labeling them because it's not clear which one goes to which one. But we now have to go back and remember, what was the upper function? Well, the upper function is the one that's the top part of the slice. So this is the upper function, and this one is the lower function. I should have really colored these in two different ways. I think that I used red for the upper function, and I used blue for the lower function. Okay, so that means that the upper one is 1 plus x squared. The lower function is 2x squared. So now we have to set up our integral. So the outermost integral has to do with where we chop. So we start chopping at x is equal to -1 up to x is equal to +1. And then we integrate, we now set up our bound on y's. So for any value of x along the way, what's the upper function, what's the lower function? So the upper function was y is equal to 1 plus x squared. The lower function is y is equal to 2x squared. And then we are integrating. Now comes in what actually our function was. Our function was x plus 2y, and then we have dy dx. Remember, the first one corresponds to the innermost integral, and the last one corresponds to the outermost integral. All right, and now we'll do the integration. So the first integral is with respect to y. The integral of some constant with respect to y is just that constant times y. The integral of 2y is y squared. So this is, we still have our x integral on the outside, but the inner one is integrated, is evaluated from y is equal to 2x squared to y is equal to 1 plus x squared. So now we substitute, they're not constants anymore, they're actually functions, and we substitute them in for y. So we have this integral from x is equal to -1 to 1 of x times 1 plus x squared plus 1 plus x squared squared. That's the upper one. And then we have to subtract off the lower one, x times 2x squared plus 2x squared squared. All of that integrated with respect to x. Let me free up a little bit of space here. So now we have to simplify this a little bit. what do we get? We have integral from -1 to 1 of x plus x cubed plus 1 plus 2x squared plus x to the fourth minus 2x cubed minus 4x to the fourth dx. So we'll simplify one more time. -1 to 1 of 1 plus x plus 2x squared minus x cubed minus 3x to the fourth. The integral with that with respect to x. And now when we do this integral, whoa, ran away, come back. When we do this integral, we get x plus x squared over 2 plus 2x cubed over 3 minus x to the fourth over 4 minus 3x to the fifth over 5, evaluated from -1 to 1. Which is equal to 1 minus 1 plus something squared minus that same thing squared is going to give us 0, plus 2/3, oops, 1 plus 1, 1 plus -1, 1 minus -1, which is 1 plus 1. And same thing here, 1 plus 1. And then we get another 0 that comes from this, and then we get minus 3/5 times 1 plus 1. So in the end, we get 2 times 1 plus 2/3 minus 3/5. Oh, how many 15ths do we have? We have 10 15ths minus 9 15ths. So we get 2 times 16 over 15, or 32 15ths. And in the end, the number is not the big part of this. The big part of this is understanding how the setup works. When you have an integral, it looks like this. Always draw the picture, figure out which way your slices are going, find the bounds of each of the integrals, and then do the integrals. All right, that's enough for now. Let's do some more examples on the next video. See you soon.